Okay, thank you. Thanks, Nick, for the introduction, and it's a real honor to serve this community. I look forward to meeting and working with lots of you over the next coming years. So I thought I'd start by echoing some things that Nick already said, which is sort of to give an update on where P4 is. I think, to summarize, things are getting real. P4 has sort of emerged from this kind of beginning as a kind of academic project. The first workshop here at Stanford had, I think, around 50 people in a much smaller room. And now you're seeing momentum across many different sectors. So in industry, you're seeing P4-enabled targets start to emerge. You're seeing products and deployments. In academia, you continue to see a lot of excitement around P4. Lots of papers at the top conferences are using P4 as a platform for research and teaching. And in the open source community, you're seeing growing momentum around things like P4.16, which was just released, and the growing set of tools that are designed for the language. So overall, things are sort of growing up, and I'm personally excited to see where P4 can go in terms of shaping thinking about programmable data planes. So today, we have a really exciting program at the workshop. We have, I think, over 200 people who registered, and we have a very full program of 26 talks and demos. These talks come from a wide variety of organizations, so some academic talks, some industry talks and demos, and they really represent quite a diverse slice of the community. You see vendors, carriers, content providers, so there's really broad interest in P4. From the sort of p4.org perspective, the thing that I think is sort of exciting right now is the release of P4.16. So many of you are aware of the earlier version of P4, which we're now calling P4.14, just to avoid any confusion. So that's a language that started being developed in 2013 and was formally released in 2014. And just yesterday, we released a new update to the language, which retains a lot of the look and feel and many of the benefits of P4.14, but it addresses some of the limitations of P4.14, and we hope will be a solid platform for the community going forward. So as I said, P4.16 retains a lot of the strengths of P4.14. So first, it's still a declarative language. It's trying to get away from specifying very low-level target-specific details. It lets you just say what you want the forwarding plane to do. And it's based on the same familiar domain-specific constructs that P4.14 had. So you can still declare header types, you can still declare parsers, you can write control flows over match action tables. All of that is still there. So if you're already a P4.14 programmer, you should be able to become a P4.16 programmer without much difficulty. And it also has many of the same higher level constructs that P4.14 had, like structured control flows, so that you can think logically about how the data plane works and don't have to worry about how that's realized at the low level. But there's some new features in P4.16 that we've added, and these, I think, significantly strengthen the language. So one of the most important is something we're calling the target architecture separation. So the idea here is that P4.14 was really based on a kind of reference forwarding model inspired by PISA, which was published in an earlier academic paper. Although PISA is a quite general model, there are targets that may want to use different kinds of models. So if you're targeting a software switch or an FPGA or even a switching ASIC, you might have a different notion about how the different components of the forwarding plane should be organized. And so P4.16 lets you express the structure of that architecture directly in the language. And so you're no longer tied to this one model. You can actually use the language to program lots of different models. And I think this is exciting because in addition to generalizing the language, it allows us to start talking about portability across targets. So if you have two targets that implement the same architecture, you now get some assurances that your program will run the same on both of those targets. Another thing we've done with this target architecture separation is adding the notion of an extern function. And this is also exciting because it lets us dramatically simplify the core language while letting each target expose whatever special features it has through this extern functionality. A couple other things that I'll just mention briefly because Gordon's going to cover them in his talk. P4.16 also has a static type system. And so this gives you richer ways of structuring the headers and metadata that are flowing through your forwarding plane. And it also makes sure that all of the primitive operations on bit and numeric values have a well-defined semantics. And then finally, P416 adds some new features for doing higher level programming. The goal here was to just make it possible to write programs that are more succinct and to encourage things like code reuse. So it's now possible to define, for example, a parser that might be parameterized on different values and that you instantiate different ways in your program. And that can let you factor out sort of common idioms into sort of libraries of code. To accompany the release of P416, we've also put on GitHub a bunch of software tools that you can use to start using P416 today. So there's a compiler framework, P4C. This is a brand new compiler implemented in C++, led by Chris Dodd at Barefoot and Mihai Budiu from VMware. There was actually a talk later today about this compiler framework. So this compiler handles both P414 and P416. In general, we hope will be a sort of solid platform for many implementations of P4 going forward. We also have the BMV2 software switch, which many of you have already started using. So you can think of this as kind of a reference software switch that you can use to test the functionality of P4 programs in a simple, lightweight way. And then there's also a bunch of other tools, things like Mininet, some testing frameworks. We have a new Docker container that was used in yesterday's development day that in general kind of lower the bar for getting your feet wet with P4. And so I encourage you to try these out. They're all available from our GitHub site. I wanted to also just point out that P416 really addresses head-on some of the misconceptions that you may have heard sort of floating around in the air. I'll just run through them one by one. One myth you may hear is that P4 is really controlled by a single vendor. And I think the reality is, if you're here, you see that there's lots of different organizations represented. And if you come to any of the meetings where the P4 language is developed, you'll actually see that there's a very open community that's developing the language, and there's not sort of control rooted in one place. Another myth that I've heard is that P4 is immature, and I think this is also not factual. So P4 is now 4 years old. We're on the second major version of the language, and we're starting to see real uses, real products and real deployments. I think P4 is sort of in its adolescent phase, sort of growing up, but it's no longer fair to call it mature. Another thing I've heard is that P4 is somehow based on a sequential model. So some of this, I think, comes from reading the specification document for the language and sort of misunderstanding what that means for an implementation. So there are parts of P4 that, to make life simple for programmers, mandate a certain kind of semantics. But P4 compilers can and do extract a lot of parallelism from that code. And so if you look at the products that are being released based on P4, they all do this. And so there's nothing that forces P4 to be limited to some kind of sequential processing. Another thing that I hear is that P4 is sort of limited to simple functionality. It's kind of you're stuck with what the language gives you. And this is something that P416 really addresses head-on through its extern mechanism. So if you have a target that has some special fixed function features that you want to expose in the language, you can define an extern function or object that encapsulates those features, and now you can access that directly from P4. And in the same vein, P4 doesn't require a fully programmable target. If you have a target that maybe has a mixture of programmable and fixed function components, P416's architectures actually let you specify where the programmable parts live, where the non-programmable parts live, and you can program them all in the same framework. And then finally, some people who have written P4 code have found that P414, for example, was sort of match action centric. If you wanted to do anything, you had to do it in a table. And this also, P416 has really addressed. The language now has many familiar programming constructs. There's a full-blown expression language, and you can use imperative statements basically anywhere in your program. So many of the restrictions that force people to sort of put their logic into tables have now been lifted, and the job is now on the compiler to figure out how to map that kind of general imperative code back onto tables. So one other thing I want to say about P4 is that with P416, we're really trying to make a commitment to the community in stability. And so I borrowed a quote from the Rust community. This is from Aaron Turan, who leads a lot of the language work on Rust. And I think it captures nicely a way that we can both allow the language to continue to innovate while making sure that people who are building targets and products and so on know that things aren't going to change from under them. And so I'll just read the quote. You know, our responsibility is to ensure that you never dread upgrading to a new version of P4. And what that means is, if your code compiles today with P416 version 1, then all future versions should be able to handle your program with a minimum of hassle. And the reason I'm not saying, you know, fully backward compatible is that if we lock ourselves into being fully backward compatible, that means it's basically impossible to ever change anything in the language, and that might cause things to stagnate. But with this commitment, we're saying that you know, your code will always be able to run on P416 versions, possibly with minor adjustments, and those minor adjustments will be relatively painless, and perhaps even the compiler will incorporate them for you. Okay, so I want to turn the floor over now to the working group chairs. But before I do, I want to thank a bunch of people who were involved in organizing this event. So first, we've already thanked Chang, but let me just recognize him again. Chang has really led the community for the last 2 years. I also wanted to thank a bunch of members of the P4 Language Design Working Group. This is a subset of the group, but these are the people who were really involved in getting P416 out the door. So in particular, Mihai, Kalin, Chris, Andy, Vladimir, Andy, Edwin, Ben, and Cole were all instrumental in kind of nailing down all the last issues and polishing the spec. I also want to thank the program committee for this workshop, Kellen, Gordon, Ben, Lorenzo, and Andy. They worked hard earlier this spring reviewing the talk proposals and demo proposals. And lastly, I want to thank the staff here who have done a ton of work over the last few weeks to set up this event, Chloe, Chris, Prem, and Mel. Okay, so with that, I want to turn the floor over to the working group chairs, and we'll start with Gordon, who's representing the Language Design Working Group.